This lesson is on data sets, measures of central tendency and spread. Make sure you take notes. Alright, so what do we mean by measures of central tendency? Well, the word central means center, and the word tendency means trend. So in math, when we have a data set, a list of numbers, a measure of central tendency tries to describe the data using a single number. So we have a big list of numbers and we're trying to decide if there's just one number that could represent this entire data set, what should that be? So when we talk about measures of central tendency, we have three basic ways that we measure that. One is called the mean, and that's the preferred measure of central tendency. So when I have a data set that's numerical, I tend to want to use the mean as my main measure of central tendency to represent those numbers. And the mean, if you recall, is just the average of something. We'll talk more about that later. The next one is called the median. The median is good for many data sets, but it's not good when the spread is large or when the data set has just a few numbers in it. And the next measure of central tendency is called the mode. And I would not use the mode. The only time that I would use the mode to represent a list of numbers or a data set is when the data was not numerical, when the data was categorical. So for example, we've all seen those surveys where they ask you a question and they ask you how you feel about it. Do you strongly disagree? Do you agree? Do you somewhat agree? Do you agree? Do you strongly agree? In that case, then I would use the mode because I can't find the average between two things that aren't numbers. So in that case, I would like to say, well, most people said they agreed. So what is the mean? Well, the mean is the average, the same thing that you're used to doing ever since the 4th or 5th grade. So the way that you calculate it is you add up all the numbers, then you divide by the amount of numbers there are. So for example, if I asked you to find the mean of 5, 12, and 7, you would just add up 5, 12, and 7, which is 24, and then you would divide by the number of numbers there are. In this case, we have 1, 2, 3 numbers, so we divide by 3, and so 24 divided by 3 is 8. So the mean of this data set is 8. So let's practice that. Take a moment to pause the video and see if you can find the mean of this data set. Alright, so first you should have added up all the numbers. So 14 plus 11 plus 6 plus 5 is equal to 36. And then since there are 4 numbers in this list, we divide by 4. And 36 divided by 4 is 9. So the mean of this data set is 9. The next measure of central tendency is called the median. All right, and the median is the middle value of the list of numbers. It's the middlemost number. All right, so in order to find the mean, we first have to have numbers that are listed in numerical order. That means we have to order them from the lowest to the highest. So take this data set, for example, 3, 13, 7, 5, and 21. In order to find the median, I first have to arrange the numbers from lowest to highest. So I did that here, 3, 5, 7, 13, and 21. And then I have to find the number that's in the middle. So the way that that is commonly done is I'll cross out the first number and the last number. Then I'll cross out the second number and the second to the last number. And I keep doing this until I arrive at the number in the middle. In this case, the number in the middle is 7. You can see that we have 2 numbers to the left of 7 and 2 numbers to the right of 7, and 7 is right in the middle. So for this particular data set, the median is 7. So what do I do if a set has an even amount of numbers? So let's take this set for example. Here I have a list of 10 different numbers. Remember, the first thing I have to do is arrange them in order. So in this case, they were already in order, so I left them in order. And then I start the procedure again of getting to the middle number. So I'll cross out the first and the last, the second and the second to the last. And I'll continue this until I arrive into the middle. And when I do that in this case, I find that there are 2 numbers in the middle. 24 and 26. Those two numbers are both in the middle when we have an even amount of numbers. So now what do I do? Well, the answer is that you take the average of those two middle numbers. So I add 24 and 26, which is 50, and then I divide by 2 because there's two numbers. And so 50 divided by 2 is 25, and the median is 25. When you have two numbers, it's kind of like the number that splits the difference. So what's right in between 24 and 26? Well, 25. The median is 25. The next measure of central tendency that you need to know about is called the mode. And remember, the mode is really only good when we have categorical data. But let's talk about it when we have a data set that's with a list of numbers. All right, so the mode is basically the value that occurs most often. So it's the easiest to find. You look at your list of data, and the one that occurs the most is the mode. However, there's a problem with this because it might just be the case that every single number is different. And when that happens, we say that there is no mode. It's also possible that we end up in a tie. There's a few numbers, that end up being repeated. So for example, the number 3 could be repeated 3 times, and the number 6 could be repeated 3 times, and that would be the highest in the list. And so both 3 and 6 would be the mode. So in that case, we have more than one mode. So when we have a mode, it's possible that we get one mode. It's possible that we get no mode, and it's possible that we get more than one mode. That's another reason why it's not good to represent a list of numbers using the mode if we're trying to find a number of central tendency, remember, which is a way to describe the data set with one number. So let's take this data set for example, 1, 5, 3, 4, 3, 2, 5, and 3. And I want to find the mode. Well, I can see that there's only one 1, so the frequency of the number 1 is just 1. And when I mean say frequency here, I'm talking about the number of times it occurs. So I'm just counting. Here's my list, and there's only one 1, so the frequency is 1. How many 2's are there? Well, I'm looking at the list. There's only 1 2. How many 3's are there? I see there's 1, 2, 3 3's. I continue on and see that there's only 1 4, and there are 2 5's. Well, the number 3 occurs the most. 3 has occurred 3 times in this case, so we say that the mode is 3. Why don't you take a moment to pause the video and see if you can find the mode of these following numbers. Alright, so I'm looking at these numbers and I don't see any repeats. Notice that none of the numbers are repeated. Therefore, that means we don't have a mode. So the answer is there is no mode. Take a moment and see if you can find the mode of these following data set. Well, we see that we have 2 8's, we have 3 9's, and we have 3 10's. So the mode is the number that is repeated most often, and we have two numbers in a tie here, right? 9 and 10. They both occur 3 times in this list. So we would say that the mode is both 9 and 10. Well, the next topic that we need to talk about is the topic of outliers. Alright, an outlier is a number that is much greater or that is much smaller than all the other numbers in the data set. So right now in this lesson, they just want you to look at the data set and superficially kind of say, hey, that number is a lot higher than all the other numbers, or that number is a lot lower than all the other numbers. In mathematics, we don't like things that are subjective, so there in fact is a way to calculate if a number is an outlier, but I'm not going to hold you responsible for that information at this time. So what I want you to do is take a look at this first data set, and you can see that I have numbers ranging here from 3, 5, 7, all the way up to 8, and then all of a sudden there's this number 36. So 36 is so much higher than the next lowest number, which would be 8, that we would say that 36 is an outlier. Just like in this data set here, we see that these first numbers tend to range from 15 to 24. And then all of a sudden we throw in the number 2. 2 is so much smaller than the next lowest number, which is 15, that 2 would be considered an outlier. So all you're doing is just looking for a number that seems like it's out of place. Like which one doesn't belong from back when you were watching Sesame Street. And if I'm looking at this list of numbers, like which one doesn't belong? Well, it's a 36. It's so much higher than everyone else. And in this list of numbers, which one doesn't belong? Well, it's the 2 because it's so much lower than all the other numbers. And so those numbers are called outliers. Outliers generally occur when there is a mistaken calculation in the data. So maybe you collected some data and then you did some calculations wrong and you made a mistake. Or it also happens when there's some kind of exception, something out of the ordinary happens, something that's rare that doesn't happen too often. So you see an outlier. So what I want to talk about is how outliers affect the measures of central tendency. This is the type of question you see a lot on standardized tests. They love to ask this question. They want to know if you understand how an outlier will affect each of the types of measures of central tendency. And the main thing that you have to remember is that an outlier will have a big impact on the mean. So like if you have a list of numbers, a data set, and you want to calculate the mean, it's generally the rule that you should remove an outlier before calculating that mean. So let me tell you an example of what I mean by that. So suppose I have a classroom of 10 senior students, 10 12th graders, and I ask them each what their annual salary is. How much money do they make in a year? And then I want to use that information to calculate the mean. So I kind of want to figure out, on average, how much do my students in my classroom make? So I go around and I ask students how much they make. Now, I personally remember when I was 16 years old, I was making $4.75 an hour washing dishes at an Italian restaurant. That was just a tiny bit above minimum wage at the time. I know minimum wage has increased a little bit at a time, but in general, high school students, because they don't have their diploma yet, are generally making around minimum wage, so not too much. Some of them are not even working. So I'll have several students say they don't make anything because they don't work. Other students make money from babysitting or doing odd jobs or helping their uncle, with landscaping on the weekend or something like that. So they might make, $100 here and there. And then my other students have part-time jobs and maybe they make $500 a month. So about maybe $6,000 a year. Other students maybe even work full-time, so maybe they make anywhere from $12,000 to $15,000 a year or a little more. So basically when I've done this in the past, I come up with a mean that's maybe around $4,000 or $5,000 for the class, what the average high school student would make in a year. So I think that's pretty representative of what they would make. Suppose, however, all of a sudden we get a new student in the class, and the new student is, say, Justin Bieber, or one of Will Smith's children, like say Jalen Smith or Willa Smith, who all makes movies, who they sing music, they make a lot of money. So let's say Justin Bieber makes like $10 million a year, and all of a sudden he joins your class. Then I ask the question, well, how much money do my students in my class make? Well, now if I calculate the mean, because remember how we calculate the mean, I have to add up all the numbers in the list and then divide by the number of numbers, in this case the number of students. So I'd add up everyone's 0, 0, 4,000, 6,000, 10,000, 12,000, 8,000, whatever it was, and then all of a sudden I'd get to Justin Bieber, who made $10 million a year, and add his $10 million in there. And then instead of dividing by 10, I would divide by 11, just one more student. But that outlier increases that mean so much that everybody in the class would now look like they were millionaires. And in fact, that's not the case. It's only him. It's only Justin Bieber that's a millionaire. So if I really want to be representative of the class and how much they make as an average, I should take him out. So that's why an outlier would have a big impact on the mean. All right, so that's what they really want you to understand, that hey, if I have an outlier, it affects the mean a lot. How does an outlier affect the median? Well, it kind of depends. It depends on a few things. One, it depends on how large the data set is. If the data set is small, adding another number on the list at the end or at the beginning could change that number quite a bit. But if the data set is larger, it probably wouldn't affect it too much. So the impact is usually pretty small, but it will affect it a little bit. And in general, an outlier's effect on the mode is very minimal. So an outlier usually does not affect the mode unless you're very unlucky. The only way I could see it happening is if you had like 2 or more outliers like at the end and they happen to be the exact same number, and that was the only number that occurred more than once in the list, and so it became the mode, which would be really rare. You'd be really unlucky to have that happen in the real world. The next thing we want to talk about is measures of spread, all right? Or another way they say that is measures of variation. So the word spread and variation means how far apart something is from its own self. In this case, we're talking about how much the data varies from its own self, all right? So some measures of spread that we use are range, which is just the highest number minus the smallest number. The interquartile range, right, which is the range of the middle 50% of the data. We'll talk more about that in a moment. And then finally, standard deviation. And standard deviation is the statistic that's most often used by statisticians when they're trying to report on the measure of spread of a data set. So that number there represents how much the data varies from its own self. In general, we'd like to see the standard deviation be low, because what that meant is the data is not spread too far apart from its own self. So if you're doing an experiment or a poll and the data doesn't vary too much from its own self, you can be confident, more confident, that that data is reliable. And the more reliable data that you have, the more accurate you can use it to make predictions. So in math, remember, that's what we're trying to do. So we'd like to see, when we have a data set, the standard deviation be low. When it's high, it tells us that we can't be as confident in making predictions as we could if the standard deviation was low. Next, I'd like to talk about quartiles and box plots. All right, the quartiles are the 3 numbers that divide the data into quarters. Okay, so by quarter, I mean 25%, 50%, 75%, 100%. So if you take a listed number and you divide it up into 4 sections, the quartiles are the 3 numbers, the first quartile, the second quartile, and the third quartile that would divide that list up into 4 sections. Since quartiles are found using the median, the data needs to be arranged in numerical order. So let me illustrate with an example. Suppose I have the data set 3, 5, 8, 12, and 16, and I want to find the quartiles. Well, the easiest one to get is the second quartile, because the second quartile is just the median of the entire data set, and we already found out how to find a median, right? I find the middlemost number. So the number that's right in the middle of this list here is 8. So we would say that Q2, which means the second quartile, is the median of the data set, and we call it the second quartile. To find the first quartile, we split it off. We take the first half of the data and we find its median. So when we have an odd number of numbers, right, I include 3, 5, and even the second quartile here, the 8, and I take all those numbers and I find its median. So what number is in the middle of 3, 5, and 8? Well, it's 5. So the first quartile of this data set is 5. Then finally, we find the third quartile. And the third quartile is the median of the second half of the data. So I'll take the numbers 8, 12, and 16, and which number is in the middle? Well, it's 12. So 12 is the third quartile. Once we have the quartiles, we can use those numbers along with the lowest number, which we call the minimum, and the highest number, which we call the maximum, to create a box plot. So what I would do first is plot Q2. So I take a number line, and since the second quartile is 8, I draw a line like I've done here at 8. And I go ahead and label it Q2 for quartile 2. Then I need to find the first quartile. The first quartile we said was 5, so I draw a line at 5. Next I take the third quartile and I draw a line on the number line where that number is. In this case it's 12. Finally, I plot them in, so I put a dot for the lowest number in the data set. In this case the lowest number is 3, so I put a dot there and I connect it to my first quartile. Then I find the maximum number. In this case, the highest number is 16 in this list, so I put a dot at 16 and I connect it to Q3. And then I finish it off by completing the box. A lot of times this plot is called a box and whisker plot because you can see we have a box and here are the little whiskers that come out at the end. What it is really just a graphical representation of the data. So the box itself, remember, represents the middle 50% of the data. So you can be confident that the middle 50% of the data is in here and the median happens at Q2. So it's just a way to visualize the data. So why don't you take a moment to pause the video and see if you can create the box and whisker plot for this set of data. Notice that this set of data has 6 numbers instead of 5. Alright, so the first thing we need to do always is find the median, which is the second quartile. Okay, so I'm finding the median of this data set and there's 6 numbers. So recall how to do that. How do I find the median when we have an even amount of numbers? Well, I need to take the average of the 2 middle numbers. Alright, and in this case the 2 middle numbers are 3 and 6. So I add them up and I divide by 2, and 3 plus 6 is 9, divided by 2 is 4.5. So I go ahead and draw a line on my line graph at 4.5, and that would be right here. Then I need to find the first quartile. Alright, so to find the first quartile, right, I need to find the median of the first half of the data. Well, we have 6 numbers, so the first half of the data here is going to be the first 3 numbers. And I need to find the median of that. Well, the median is the number that's in the middle, and the number that's in the middle in this case is 2. So the first quartile is 2. So then I go to 2 on my number line and I draw a line there. Then I go ahead and find the third quartile. And the third quartile is just the median of the second half of the data. Here's the second half of the data here, 6, 8, and 15. And the median means the middlemost number, or the middle number in the middle, which in this case is 8. So I take my 8 and I plot it on my number line, and it's right there. And I go ahead and label it Q3 for quartile 3. Alright, so I have my first quartile, my second and third quartiles, and now I need to find my max and min. Alright, so that just means the lowest number and the highest number. So the lowest number on this list is 1, so I go ahead and I put a dot at 1 and I connect it to the first quartile. Then I put a dot at 15 and I connect it to the third quartile. Then I finish off this problem by completing the box. And there we go, I've drawn a box and whisker plot to represent this data. Next, I'd like to talk to you about interquartile range, or what we call IQR. The interquartile range is just the difference between the third quartile and the first quartile. So basically it's finding the range of the middle 50% of the data. So all we do to find that is take the third quartile and subtract the first quartile. So remember, we need to know what the third quartile and the first quartile is in a data set by calculating it just the way we did before. So in this list of numbers here, remember I have to make sure that the numbers are in order. That's how we find medians. So I've ordered the numbers here. They're already in order. And then I identify the third and the first quartile. Well, the first quartile is the median of the first half of the data. So it's 5. And the third quartile is the median of the second half of the data, which would be this, right, when we have an odd number of numbers. And so the number in the middle of 8, 12, and 16 is 12. That's the third quartile. And then if I want to find the interquartile range, I just subtract those two numbers. So 12 minus 5 is 7. All right, so the next, finally, measure of spread or measure of variation that is used most by statisticians is called the standard deviation. All right, remember what the standard deviation represents, right? It's trying to tell me how much the data varies from its own self. The standard deviation is always a number that's greater than or equal to 0. 0 would mean that the data does not vary from its own self. The only way that happens is if you have a list of numbers where every single number in the list is identical. They're the same. So for example, if I had 10 numbers in a data set and they all happen to be 2.1, then we could say that the standard deviation was 0 because all the numbers are the same. The data does not vary from itself at all. They're identical. All right, in the real world, right, that rarely or never happens. All right, so what happens usually is the data will vary and you're trying to get that number to be as small as possible. And the larger that number is, the more the data varies from its own self. Here I've included the formula for standard deviation. I know it looks really complicated, so I don't expect you to know what all these symbols mean just yet. That's why I've written out the steps to calculate the standard deviation here. And the first step is to find the mean of the data set. All right, and in this equation, the mean is represented by what we call here x bar. After we find the mean, we find the difference between the mean and every number in the data set. That means I have to take every single number in the data set and then subtract the mean from it. After I do that, I square all those differences, so I raise them to the second power. So I take every number in the data set, I subtract it from the mean, then I square every single one of those numbers, and then I have to find the mean of all those squares. That means I have to add up all those numbers and divide by the number of numbers there are in the list. And then the last step would be to take the square root. All right, so let's practice taking the standard deviation of a data set. Here I've limited the data set to just 5 numbers. As you can see, this process can be quite tedious and long. So the larger that list of numbers is, the longer it would take. If I had 100 numbers, it would take a very long time to calculate the standard deviation. That's why today we use mostly technology to calculate it. And in a moment, I'll show you how to calculate that using an Excel spreadsheet or basically any kind of spreadsheet. So the first thing we do, right, step 1, is to find the mean. So that means I should add up every single one of these numbers and divide by the number of numbers. So here I've added them up and I've divided them by 5 and I got 4.2. Next, I have to take every single number in the list, the 3, the 5, the 4, the 7, the 2, and I have to subtract that mean from it. So I take 3 and I subtract 4.2. I take 5 and I subtract 4.2, and so on and so on and so on until I've done it to every single number. And you can see the results here, they're listed in red. So now I take all those red numbers, right, the measure I got from subtracting the mean, and I square them. I raise them to the second power. So that's what I've done in this next step, the third step. I've raised them all to the second power. So now I have all these numbers. And then I need to find the mean of all those numbers. So remember how we find a mean again. I add them all up and I divide by the number of numbers. So here you can see I've added them all up and I divided by 5 because there are 1, 2, 3, 4, 5 numbers on the list. And when I did that, I got 2.96. And the last step is to take the square root of that number. So I take the square root of 2.96 and I get 1.72. So the standard deviation of this data set is 1.72. Now I want to show you how you would calculate that without using, hand calculations. So how to use technology to calculate it. And the best way to do it is a spreadsheet. All right, so if you have a Windows machine and you have Microsoft Office, you can use Excel. If you have a Google Drive, you can use Google Sheets. Basically, any spreadsheet is capable of doing this. The Mac computers have their own version of a spreadsheet. So here I've gone ahead and opened up a spreadsheet. In the first column, I'm going to go ahead and I'm going to put our data set. So I'm going to create one. I'm going to make one up here. So I'm just going to start typing in numbers 3, 5, I don't know, 6, 8, 9. They don't have to be in order. 12. I could put 2 again. Maybe there's another 4. Maybe there's a 7 and a 4. So I have quite a few numbers here. Now I want to calculate the standard deviation. The way that I do that is I go to any open cell, any open box here, and I click on it, and I type the equal sign. So this lets Excel know that I'm about to enter a formula. So I say equal, and to find the standard deviation, I type STDEV. That's short for standard deviation. You can see here that it pops up with the specific formulas it has, and there's many different forms of standard deviation. You're just interested in the general one, which is STDEV. So you click on it. Now I have to tell it, Excel, what numbers I want it to take the standard deviation of. Well, so I take my list and I select and I highlight all the numbers in the list, because that's the list, that's the numbers here that I want it to take the standard deviation of. Then I hit my close parentheses, I hit enter, and it calculates the standard deviation for me. So the standard deviation of this list here is 3.05. Just to do something kind of cool, let's see what happens if I throw in an outlier in this list. I don't know, so here I have my list. I've seen the standard deviation is a little more than 3. Let me throw in a number that's like much higher than all the other numbers in this list. So here I see the highest number is 12. Why don't I make a number like 4 times bigger than that, say like 48. I'm going to throw that in my list. Look what happened to the standard deviation. It went from 3 to almost 13. Right? Because remember what standard deviation represents, right? It represents how much the data is spread out from its own self. So I had all these numbers that were pretty tight, 3, 5, 6, 8. Then all of a sudden I threw in 48. And look how much it increased the standard deviation. All right, so that concludes today's lesson. Remember to go back into your course announcements and click on the asynchronous questions and submit them to get a score for this assignment.